All right, everybody. Hey, my name is Dan, and along with April, Jenny, Chrissy, we're Team Lysten. Virtual classrooms, as you might know, pose a unique problem in which students and professors don't have the same kind of relationship that physical classes can foster. We're four data science graduate students with over 30 years of combined experience as students of higher education and are passionate about building upon and improving the virtual higher education experience. Our product, Lysten, uses machine learning to collect and sift through student feedback and extract actionable insights. Our product provides a more informal, accessible, and real-time mechanism for sharing that feedback. Tonight's agenda is as follows. I'll speak to a little bit of background and research. People will give them a demo of the Slack platform. Jenny will talk about modeling and processing. Chrissy will then explain a little bit more about data consumption platform for professors and administrators. Then I'll wrap it up with our product evaluation and next steps. So on this screen, you can kind of see that we're grateful for all the help that we've received for the community. Now on the next slide, what we did is we conducted a really wide survey of students to understand their wants, needs, and points of pain, and we're able to draw a number of conclusions. But hands down, the most popular way to provide feedback presently is via the formal surveys. Students in online classes have a lot of work and responsibilities to juggle, particularly in a part-time program, and providing feedback is only top of mind when there's a strong enough trigger to cause action. Presently, this is the semi-term survey that has its limitations. On the next slide, what you can see is we were heartened to hear that our hypothesis, though, of providing a less formal, more snackable means of providing feedback resonated strongly with many of the respondents. So on the further one slide, we conducted a number of interviews and follow-up interviews with faculty and staff and learned that some faculty already have implemented surveys that got to the heart of what we were proposing, more targeted, frequent feedback. Faculty also appreciate more timely feedback that was more focused and actionable on topics that they would be able to change and modify. Faculty and staff mentioned the importance of taking data within context of what was going on in class. And finally, the unique value prop of our Viz is that it provides a means to observe longitudinal trends. And now I'll hand it off to April.
Okay. So we created a Slack chat bot named Lisa to collect feedback from students. Lisa is built using Node.js module BotKit, and the students' feedback is stored in MongoDB for downstream analyses. Lisa conducts a short personal interview with every student who messages, where administrators can have Lisa initiate a chat, or students can begin by saying, "Hi, Lisa." Students are greeted with a few onboarding questions, including the specific topic to be discussed, the course number for which this feedback is referring to, instructor for the course, how many hours students expected to put in each week for this course, and lastly, we asked them to rate the overall experience they've had so far with this topic using emojis. Lisa engages in a swift conversation, asking for two main feedback. First of which is asking for something that is going well in the course that should remain the same. And the second is something that needs to be improved or could be changed. And Lisa asks if there is any additional feedback that a student would like to give. And then to rate on a scale from 1 to 7 on how valuable this topic is to the course. From here, students have the option to discuss different topics by clicking on a thumbs up emoji or to end the conversation.
Awesome, thanks April. So now, how are we actually going to turn that into how we're going to process that? So we'll talk about the next phase, which is the data processing and topic bundling. So we've got the student feedback from Slack. We want to turn it into actionable data for admins and professors. So we decided to generate some topic models to identify subtopics within the higher level topics that students have already chosen as part of the Slack workflow. We did want to do this for two main reasons. One, we wanted to identify recurring and emerging topics over time, with not limiting ourselves to those high-level topics that are structured. And we also wanted to save professors and admins the time it would take to actually do this manually. So to actually create our models, we had access to two very different data sets. So the first one came from the MIDS course recs channel, which is where a bunch of us leave comments about our different courses. We went there, we pulled out 237 individual pieces of feedback that were de-identified, so anonymized, but they covered all 15 MIDS subjects and ranged across sections and instructors. The second data set came from Rate My Professors, and it had 187,000 rows of general course survey results. So obviously not mid-specific, but very, very broad in its coverage. It covered 334 different subjects in more than 15,000 different classes. So very different data sets. One large enough to actually what we were actually trying to accomplish. So we ended up deciding to use the Rate My Professors data set to train our general topic model, come up with some topics, and then evaluate those against the Slack data set to evaluate how well those topics actually apply to our use case. All right, so now the fun stuff, actually generating the model. So to derive the topics from our data, we cleaned and prepped both data sets and then used that Rate My Professor data set to train a latent derelict allocation, or LDA, model. This model loops over a training corpus of text to identify a specified number of topics that are present in that text, and then the words that are associated with those topics. So that then for any new text, which is the kind of flow that's depicted here, it uses the words that are present in that text to predict the most accurate topic for that. So we generated dozens of different models. We varied the number of passes over our training corpus, the number of iterations over the individual pieces of text in the corpus, and then finally the number of topics to actually be extracted to try and come up with the best model possible. So for actual evaluation, to determine how well we did, we evaluated both by their performance on our Slack data set, which we talked a little bit about earlier, but we also looked at two numeric measures of topic coherence, which are graphed here. So these measures look at how often words in a topic tend to co-occur together. The more often they co-occur together, the more coherent the topic is. So we saw the best performance across both of the measures around 11 and 14 topics, which are the two kind of circles there. So we focused in on that area when we were finalizing our model. And speaking of finalizing the model, we ended up with our final LDA model, which was generated using a subset of our original Rate My Professors data set. So we specifically looked at feedback from subjects related to data science, so statistics, computer science, and so on. And then we used our course recs data set to validate our labels, see how they did, and our 14 topic model performed the best. Interestingly, though, 2 of our 14 topics ended up being so general, and they just ended up applying to more than 50% of our text. So we pulled those 2 topics out manually and ended up with a final 12 topic model. And now Chrissy will actually talk about how we use this as our visualization.
Yeah, so we wanted to make sure that all this work that we've done and all the data that we collected was easily digestible for the professors and administrators that are going to want to be using it. And so we created this dashboard in Tableau that'll help them sort of consume the information quickly and clearly, and also we hope impart less bias in the process than a human trying to sort of read all these comments and find patterns, but with their own biases in there. So this is the first dashboard. We're calling this the topic stream dashboard. And at the top here, you've got a filter by course number. So you can actually make this, just core MIDS classes if you like, or just advanced classes, or just ones that have to do with machine learning or anything like that. But once you've got your classes selected, hopefully this dashboard can help you answer some questions about how students are feeling in the classes. The first sort of question is just what's on students' minds at any given time. And so at the top here, we've got these trending topics in sort of a stream graph format, and you can see what is most important or what people are providing the most comments on week to week. And so, for example, here you can see that live session, there's lots of comments sort of at the beginning as people are settling in, and lots of comments at the end, perhaps as live session is getting more intense or more interesting, or something, but in the middle it sort of slows down, whereas something like assignments is just constantly on people's minds. Another sort of thing that people can address with this dashboard is drilling down into a given topic and trying to get a general idea of how people are feeling about it. So we've got down here sort of a word cloud that provides a course summary, and then sort of some sentiment analyses. And so, for example, someone could come in here and try and find out how people are feeling about assignments. You got lots of red words in the word cloud here, so that corresponds to a negative sentiment. And you can see in the sentiment distribution also there's sort of a lot of negative sentiment around assignments. Interestingly, in the trend graph, you can see at week 12, people were feeling pretty good about assignments. They've got high sentiment value here, and then week 13, it sort of tanks, and so maybe the professor could see, oh, something's going on. Either I didn't give it back fast enough, or the week 13 assignment was really difficult, or some such like that. And you can see, things like feedback is a big word here, meaning that might be an issue. And then the subtopics that Jenny was talking about show up in this menu. So you can either further filter or even just look at this list to see kind of what subtopics about assignments people are thinking about. As another example of this sort of thing, we can look at instructors and see people generally have a lot stronger positive feelings about the instructors, which is great. So lots of green words in this cloud. You can see things like Slack and answering questions perhaps, and so people are feeling good about those aspects of their relationship with their instructors. The distribution here of sentiment is interesting, and that it's maybe a little bimodal. And so this is something for professors to take note of, that some people are feeling really good and confident about their relationship, but there is a contingent here that's sort of having a harder time. And again, we've got some interesting peaks and dips that might correspond to something going on in class that professors could look at. So those are some really powerful tools that instructors and administrators can both use to sort of dig deeper into the comments. But we did hear from a lot of our users that we interviewed that sometimes they just want to dig into the raw comments and really read every word. And so we've got a student responses dashboard as well, where professors and administrators can just get right down into the details. And so you can read every comment here. You can filter if you want to make it a little bit shorter to consume, and then there's a download link at the bottom here if you want to sort of package this and take it with you to go. But we're hoping that these dashboards make things a little bit easier to consume and easier to play with for our professor and administrator users. And so I'll kick it back to Dan to tell you about how it went.
Thanks, Chrissy. So we conducted a fair amount of user testing and were able to derive a lot of really interesting results. On the next page, we also definitely sort of came up with some new challenges for us to face and have overcome. So the Lysten platform makes strides in abrogating many of the pain points of the current feedback paradigm, but as we develop the platform and talk with all the users, new challenges have emerged. For instance, for students, they want confirmation that their feedback has been received and is being acted upon now. For faculty and staff, they want to ensure that the data is representative of the entire student body. So we had a number of key learnings and takeaways on the next slide, such as, we've developed a platform that helps engagement and timeliness of feedback by going where the audience is, that's Slack, for the iSchool. We realized that this isn't a one-size-fits-all solution, but works for a non-trivial majority. Different stakeholders want different views of data, consume data differently at different times, but want to be able to also analyze the individual data themselves if necessary. And finally, just like the feedback itself, all summarization and statistics yielded from the data must be taken in context of how it was collected. So now on the next slide, sort of looking forward, our future steps are that, as we talked about earlier, expectations can be an important driver of student satisfaction, and we would want to include more blocking and analysis on this. We'd want to integrate the components of our data pipeline for automatic ETL and analysis. Further, we need to develop further compliant authentication where we roll this out. And finally, our two final points of we're continuing to chip away at remaining biggest points of pain in the feedback paradigm. Thank you so much, and we're happy to take any questions that you might have.